Honestly, I don't have the right words to describe the feeling that comes from studying the universe. As Carl Sagan said, astronomy is an experience that humbles and strengthens character and expands the scale of the universe and gives us a reason to be humble. But this isn't the only feeling that most people have. Many people also feel awe and wonder at the sights and environments in space that we have observed, especially as technology continues to advance. And in short, space is just really awesome. Before we begin, it might be better to clarify first what the title of this video really means. It's better to say the 10 largest, according to current human knowledge, features, objects, structures, and other things in the universe arranged by type. And it's just a bit long and not as catchy, but that's the idea. But before we start that, if you're new to our channel, please don't forget to subscribe so you'll always be updated with videos like this. Number 10, the largest black hole. The same conditions mentioned for the largest star also apply here. But beyond that, the largest known black hole is millions to billions of light years away from us. The event horizon of a black hole is the boundary beyond which not even light can escape its gravity. The accretion disk consists of dust, planets, and stars orbiting the black hole outside its event horizon. The unusual light coming from the accretion disk of a supermassive black hole is what we call a quasar. However, the light from S514 plus 81 belongs to a special class of extremely bright quasars called blazars. Its event horizon, the sphere of material from which not even light can escape, is so large that it has a diameter of 237 billion kilometers. It could fit our entire solar system from the Sun to Pluto's orbit 37 times. Its mass is about 40 billion times that of the Sun, though exact measurement is difficult. And for comparison, an ordinary stellar mass black hole is only 2 to 4 times the mass of the Sun. Number 9, the largest nebula. The word nebula is vague, so it's more accurate to say H2 regions, since they're among the most beautiful sights in the sky and play a key role in star formation. The New General Catalog 604 is the largest known H2 region and a gigantic engine of star creation. It's about 1,500 light-years wide and is located in the Triangulum Galaxy. It's so bright and large that it would appear even brighter than Venus if it were as close as the famous Orion Nebula. There may be larger H2 regions elsewhere in the universe, but their faint light means we haven't found them yet. The nebulae get their light from the stars forming within the dust, resulting in unique colors. But when the H2 region starts forming stars, their lives are only temporary. The very stars they create ionize the dust with their intense light. And when a supergiant star explodes as a supernova, it will disperse most of the dust. This is why the H2 region lasts only a few million years. So take the opportunity and observe these amazing star nurseries while you still can. Number 8, the largest galaxy, IC 1101. When referring to the largest galaxy in the universe, it's important to note that the largest known galaxies are usually millions to billions of light years away. That's why it's difficult to measure their size exactly because of the scattering of light in space from such a distance. Our own Milky Way has a diameter of 100,000 light years plus a few thousand light years and is made up of 100 to 400 billion stars. It's so huge that it's hard to imagine, but our galaxy is only considered mid-size, and in the vast universe, there are truly gigantic galaxies. The IC 1101 is a brilliant yellow supergiant elliptical to lenticular galaxy and is currently considered the largest known, with a diameter of about 4 million light-years plus several 100,000 light-years. At this size, it could contain 10 to 100 billion stars each with its own solar system and possibly planets. And it is located more than 1 billion light-years away from us. The boundary of a galaxy is somewhat uncertain, so even though IC 1101 has the largest halo of diffuse light, There is debate about whether the gas surrounding the galaxy should be considered part of the galaxy. Even with this caveat, IC 1101 is the largest known galaxy to us so far, and it's possible that even larger ones may be discovered in the future. Number 7. The largest galaxy, Protocluster New Blob. A galaxy protocluster begins as a large cloud of hydrogen gas in the early universe that provides the blueprint for galaxies and galaxy clusters. The newfound blob discovered in 2005 by a research group at Tohoku University is only a temporary name for now. It spans 200 million light-years and is about 12 billion light-years from Earth. And this means that its structure was already complete just 2 billion years after the universe began. It is made up of hundreds to thousands of galaxies and protogalaxies, as well as bubbles of hydrogen gas illuminated by stars that are forming hundreds of times faster than those in the Milky Way. These hydrogen bubbles are called Lyman alpha blobs, which are rare and massive structures of hydrogen gas that emit light at the Lyman alpha line. A special filter allows large, heated hydrogen blobs in space to be seen from great distances. Most Lyman alpha blobs span 10 to hundreds of thousands of light-years, and despite being larger than the Milky Way, are much denser than typical regions in space. This density is important because Lyman alpha blobs are likely the early stages of galaxy clusters, and this matches the hundreds of Lyman alpha blobs found within the newfound blob. Number 6. The largest supercluster, Horologium supercluster. As for the supercluster, the Horologium Reticulum supercluster, often referred to as the Horologium supercluster, is the largest supercluster of galaxies known to us so far, with a length of 550 million light-years. The galaxy superclusters are exactly what they sound like, huge collections of hundreds of thousands of galaxies that are loosely connected by gravity within a vast region of space. Our galaxy is part of a supercluster. Our solar system is just a small part of the Milky Way, which belongs to a small group of galaxies called the Local Group. And the Local Group is just a small part of the Berger supercluster, which may also be part of the proposed Laniakea supercluster. Although it is still just a proposal, the Laniakea and Horologium superclusters are almost the same size. Currently, the Horologium supercluster is the largest, and it is located 700 million light-years away from Earth. Because galaxies are held together by gravity and the not yet fully understood dark matter, it is also reasonable to think that there are regions in the universe that are almost empty in comparison. Number 5. The largest void. The vastness of the universe that we have recorded is extremely hard to comprehend, and even the smaller parts, like our galaxy, can make us feel small and alone on our tiny planet. We're just lucky that the Milky Way is on the edge of a massive supercluster instead of freely floating in a void, the loneliest place in the universe. Andromeda, one of our closest neighbors, is about 2.5 million light-years away. But in a void, the distance to another galaxy or cluster could be about 10 to 100 million light-years. If the Milky Way were alone in a large void, our sky would be darker and we wouldn't know about other galaxies until the mid-20th century. 1.5 billion light-years from our galaxy lies the giant void. It's so huge that it's even larger than the biggest supercluster we know, with a diameter of about 1 billion light-years. There are a few isolated galaxy clusters inside it, but none of them are gravitationally bound because they are so far apart from each other. If supervoids give you existential dread, you might get even more frustrated. Because we're also not exactly at the center of a galactic metropolis, there's new evidence supporting the Keenan-Barger-Cowie void, which could be considered the largest known supervoid, with a diameter of 2 billion light-years. Our galaxy, along with a large part of the Laniakea supercluster, is inside it, which creates a significant barrier between us and the wider universe. Fortunately, we are not alone or at the center of the Keenan-Barger-Cowie void, a fate shared by some of the less fortunate galaxies. Number 4, largest cluster group. That's right, the actual name is the large group, often shortened as LQG and OU. The name is actually a bit funny and confusing. If we look at the universe in the distant past, we can see many black holes connected by gravity, and each one has a bright active quasar. These quasars form the basis for galaxy clusters and filaments. The huge large quasar group is located 9 billion light-years away and is composed of 73 quasars that span a distance of 4 billion light-years. This structure is so large and dense that it may violate the current cosmological principle, which states broadly, the universe is isotropic and homogeneous, which means if you take large cubes of space from different parts of the universe, each one should have almost the same amount of matter. Since the cubes are estimated at 300 million to 1.5 billion light-years, some large quasar groups, galaxy walls, filaments, and perhaps a supervoid linked to the cosmic microwave background cold spot are included in the accepted principle. Although there is a wide debate among astronomers, the huge large quasar group is an exceptional example of large cosmic structures. Number 3, Hercules Corona Borealis Great Wall. The Hercules Corona Borealis Great Wall is currently the largest known singular structure, which can reach up to 6 to 10 billion light-years. Although the name focuses on 2 constellations, it would be more appropriate to call it the Great Gamma Reverse Wall because that's how the structure was discovered. When hypergiant stars collapse, the north and south poles of the forming black hole emit powerful gamma rays. Usually these bursts are randomly distributed. But it was discovered that many bursts with a 44% redshift are statistically close to each other in one region of the sky. That covers Draco, Lyra, Bodes, and the entire Hercules and Corona Borealis. This gave rise to the hypothesis of a massive gravitationally bound structure 10 billion light-years away, covering almost 1/8 of our sky. There's debate over whether this is a supercluster or filament. A round shape is usually an indication of a supercluster, but its size is 20 times larger than the biggest known supercluster, so it's really unclear. Whatever the case, the galaxies inside the Great Gamma Ray Burst Wall are among the millions that contain trillions of stars inside. Number 2, the cosmic web. Our planet is just a small part of a vast solar system, which in turn is part of the much larger Milky Way galaxy. Our galaxy, in turn, belongs to the local group of galaxies, which is part of the much larger Virgo supercluster, and perhaps also part of the even larger Laniakea supercluster. Between these superclusters are vast voids, almost devoid of matter, forming huge empty spaces where galaxy filaments form around them, gathering most of the matter. The cosmic web is thought to be a connected network of dark matter filaments that binds almost all the matter in the universe. It's like a web stretching in all directions, where the superclusters and galaxy filaments form the strands of the web, and the empty spaces serve as the voids. You can visualize it like the inside of foam or a sponge. But my favorite comparison is how the simulation of the cosmic web resembles the neural pathways of the brain. A constantly moving, interconnected structure spanning the universe, including almost all of the estimated 2 trillion galaxies in the observable universe. This is the theorized cosmic web, and if it exists, it's likely the largest structure in the universe. It's hard to feel smaller or more insignificant, but at the same time, we're part of something so vast and amazing. Number 1, space. The farthest distance we can observe in the universe is about 46.5 billion light-years in every direction. That's why what we call the observable universe has a diameter of about 93 billion light-years. This distance is our cosmic horizon, the farthest we can reach among the stars. Although we still don't know how big the entire universe is for now, the universe is expanding at a rate of about 22 kilometers per second per million light-years. A unit we call the Hubble constant, even though it's not really constant. Space, or more precisely, space-time, can be thought of as a gigantic fabric with endless layers where all matter and particles exist. The fastest thing that can move on this fabric is what we call the speed of light. However, the fabric itself can expand faster than light in all directions. It doesn't mean that distant galaxies are moving or will move faster than light. Instead, the distance between us and the galaxies is expanding faster than light, and the speed of this expansion is increasing as time goes by. As a result, we will only see a smaller part of the universe in the future since light from distant galaxies will stop reaching us. In the end, the only thing that any life in the universe will see, aside from its own galaxy, is a vast and endless darkness. However, this event will only happen after billions of years, so it's better for us to start exploring the universe while we still have the chance. We could really spend many more minutes on this topic. However, this is already the longest video we've ever made, and we've also run out of words we can use for big. And overall, space itself is the biggest thing in the universe, and this is the thing that really makes us feel how small we are. But we are part of something so vast and amazing. Now what can you say about our video today? Let us know in the comments. And before we end, please don't forget to subscribe so you'll always be updated on our next videos. So once again, thank you so much for watching. This is Noel Polo TV. See you on my next video.